So we're going to walk through queuing and running jobs. So Mira's queues are broken up into three parts. There's prod long, which is restricted to that first row at the top of the machine. And then prod short and prod capability, which can run, and jobs in those queues can run anywhere on the system. We do our best to make sure that the documentation that we've got online is up to date and current. The thing to kind of look for in general is that we will allow you up to a max running 5 jobs per user, and you can have about 10 and 20 jobs queued at any time. This means that if you've got a very large series of jobs, you may need to look into workflow software such as Fireworks as a way of managing those jobs, or some sort of custom scripting. What do those jobs actually mean? Well, for prod, essentially you must be a valid insight or a valid project with a positive balance. These are jobs that use between the smallest of the underlying queues prod short. Will give you between 512 and 4,096 nodes. Again, the smallest partition you can have on Mira is 512 nodes, hence the minimum queue size is 512. Prod short is jobs equal up to or shorter than 6 hours. I'm actually going to jump over prod long and go to prod capability, which is anything from 4K, so 4,097 nodes or greater, up to a full machine size. Prod long is kind of our point of it gets picked on a lot, but it is for jobs that are sub capability size, so smaller than 4,096 nodes or smaller, that are using greater than 6 hours. In terms of priority, we always favor prod capability. Anything you can do to get into the capability queue, bundling jobs, occasionally sacrificing efficiency for going up in size, it will pay off. Scaling pays. So again, if you have a 512 node job and it takes forever to run, it probably will continue to take forever to run. However, if you have an 8K or larger job that is struggling to run, we will help it out. There's a backfill queue that's for projects that have gone into the negative. Backfill receives no priority, but can run from 512 nodes and up for up to 6 hours. And then earlier Ray had mentioned the magical 5-dimensional torus, which is impossible to visualize unless you're, I guess, from Berkeley. And in order to make wiring, in order to be able to make job packing a little more efficient, the 1024 tori is not a true torus in all 5 dimensions. It is a mesh, I believe, in the D dimension, such that they can put one rack job side by side. If you need the full torus in all dimensions, then there are separate queues for prod 1024 torus. Similarly, in order to create a larger number of 32K partitions and enable, again, slightly better packing, there is a separate prod 32768 torus, which is a torus in all dimensions. Cetus, things are a little bit easier to explain. The biggest thing to watch out for is the maximum wall clock time on Cetus is an hour. Again, this is to kind of push people to reserve Cetus for testing and development runs. The one exception is there is a prod queue on Cetus, but that is a special cases queue. So again, the vast majority of users, 99.8% of users, are limited to an hour. However, if you or your PI get stuck on something, say calculating, say, a waveform function, or there's some sort of decomposition that just due to the laws of physics will not scale and is blocking your ability to run, say, a larger simulation, then feel free to reach out to your catalyst or to support at alcf.analytic.gov, and we'll work with you to figure out if ride capability becomes a little more important. Everything, by the way, on Cetus matches what's on Mira, so it's all the same software, you're mounting all the same file systems. So again, if it's short, under an hour, and it looks like it's something that might back up or take a while to get through on Mira that you just need for testing, run it on Cetus. Vesta has its own file systems. It's a separate entity. For the longest time, I referred to Vesta as kind of like our open mic night. It was a place that was open to just about anyone, ranging from high school students to folks who had never seen a Blue Gene before or never scaled before. And so it's got a slightly longer wall clock time at 2 hours. And that's really, again, meant to discourage people from using Vesta for too much that's production oriented, but to allow them to be able to do serious debugging and scaling sessions in preparation for putting in an ALCC or an insight proposal. One thing to think about is there's a term tabula rasa, or clean slate. As Ray mentioned earlier, we don't run Linux, we run CNK. CNK is a single user operating system. Every time you submit a job and a job begins to run on a Blue Gene system, you get a clean slate, tabula rasa. The nodes are being completely rebooted. There's nothing left in memory. The network is actually completely reprogrammed for you to your specifications. There is absolutely nothing left in time. The flip side of this, the disadvantage, is that you have to be a little bit patient and take into account boot times. So it can take between up to 7 minutes to boot the full machine. And as about on average, it's usually between 1 and 3 minutes. Where this also becomes important is as you're running larger jobs, in order to keep you from having to requeue if something goes wrong on boot, our scheduler Cobalt will attempt to boot things 3 times. So when you're calculating job lengths, you want to work in maximum boot times. So if you have, say, a full system job that lasts an hour, you will actually want to make sure that you've actually added in maybe an hour, made it an hour and a half to accommodate the possibility of reboots. So is anyone here familiar with PBS or Torque, Maui, or run on any of the NASA systems that use PBS Pro? Well, Cobalt is very, very similar to those systems in that they follow, there's a standard that POSIX spit out. The only scheduler on the market that does not have POSIX interfaces is Slurm. Just about all these commands should be very, very familiar. Just to run through them, there's QSub, which will submit a job. First, I should turn off caps lock. QStat, which will show you in the queue status, what's running, what's queued. QDel, which will delete a job once that, and by the way, it'll only delete your jobs unless you've actually added members of your project or group as someone who can modify jobs. There's QAlter to alter batch job parameters, and we'll go through these again in a minute. QMove to move jobs between queues. QHold to place running jobs on hold, while non-running jobs on hold. So say you were counting on a file transfer from another site to finish, or you discovered a problem with your binary in another run, you can place jobs on hold that way. QRLS or QRelease, which releases jobs which are on hold. And then there's queue avail, which will list current backfill slots available for a particular partition size. So say you just want to get something in while the system is draining for a larger job, you can use queue avail and see what's possibly out there. The other two commands to kind of keep in mind are show res, show current and future reservations. About every 2 weeks, we get an email asking why jobs aren't running. And the general answer comes back, well, it's because there's a system-wide reservation or the system is in maintenance. And so show res will show you those reservations when they're coming up and what partitions and users are on them. And then there's user res, which is kind of strangely named, but it will release a reservation so that way other users can, so say I've asked for 12 hours for a reservation for some scaling, I'm not going to use my full 12 hours. I can release my reservation and other users can go on to use the machine. Any questions so far? Awesome. Either you guys are the fastest learners I've ever had, or I am rocking it, or we'll find out in a little bit that things were broken. So QSub has a lot of options, and some of these are BlueJeans specific. The options that you need to watch out for, just to kind of run down the standard options. And this is, again, all of these commands have man pages on the system, and they're documented in our user guide. But the big ones are -A for project. So what are you charging? -Q for queue. You don't have to choose a queue for Mira or any of our systems. If you just QSub, it will look at the job parameters and your project and will try to route things accordingly. But sometimes if you've got a reservation, reservations have their own queues. So you'll want to specify a reservation queue or use QMove to move things from a general queue into the reservation queue. -T, you can do time in minutes, or you can do hour, minute, seconds. Either way. -N, number of nodes, and that's the number of nodes that you're going to run on. One thing to, again, if you ask for fewer nodes than are within a partition, you will still wind up on the same number of nodes as the next partition size up. So say if I'm on Mira, I ask for 1 node, I will get 512 nodes. I will still run on 1 node, but I will get 512. There's --proc count, which think of that as the number of cores available. So maybe I have, and I'll jump forward to mode. So again, Ray earlier mentioned that there's the concept of mode, which in hardware decides how many cores and how much memory per core is available. So basically it's taking that hardware node and partitioning it. Proc count is kind of like setting the number of, saying the number of cores that are in use. So even if I have chosen, say, C64 and a high number of cores, I don't have to use all the cores that I've requested. -env, ENV for passing forward environment variables. The next piece down, the other mode to think about is script. So all of these options you can put into a bash script and use the bash script as a way of recording income and variables. There's the command, which can be either the binary on the BlueJean, or it can be the script file if you specified mode --script. -O to specify the output file prefix. It defaults to job ID output and job ID error. I believe you can also redirect the error. -M to send email on job start and end. One that's also kind of important is --dependencies. So you can set dependencies on other jobs that are in queue. So if you've got a situation where job 100 and job 102 must finish before job 104, you can set dependencies for job 104 on 101, on 100 and 102. So that way you can be sure that things run in the order that you intended. If a job exits with a non-zero exit code, the dependency will not be met. It'll just be held, and you'll manually have to go in and either release or change the dependency. And then there's -I for an interactive command. Again, you cannot log into the BlueJean compute nodes. Instead, you find yourself on a shell on a login host, but a partition has been assigned to you, which then you can use the run job command to run things on. Any questions so far? Cool. I promise I'll also stop reading to you guys and bang on keys in maybe in a minute or two. So again, we kind of went through the start of proc count and mode. So again, mode C1, you've got 1 rank per node, but you can use all the threads. Mode C2, 2 ranks per node. So one rank can see half the cores and half the memory, and the other rank can see the other half the cores and half the memory on each node. And this continues up through C16, where you wind up with 1 rank per core, but that one rank can see 1/16, so 1 gigabyte of the memory, but it can still run up to 4 hardware threads on that core. C32, we've got 2 ranks per core, and C64, we wind up with 4 ranks per core. You can then use proc count to adjust the number of overall threads, or if you're using OpenMP threading, in any of the modes, you can use OMP num threads to say how many of the available hardware threads you're going to use. So in mode C1, you could do OMP num thread 64, mode C16, OMP num threads 4. By the time you get up to mode C64, the only valid number of OMP num threads is 1, because all of your hardware cores have been subdivided. So I had also mentioned script jobs. So rather than specifying -- mode, see something followed by the binary, instead you wind up with -- mode script and then the script name, and it's a bash script. After the shebang, that first line that says, hash bang /bin sh or /bin bash, immediately after that line, you can add Cobalt directives. So there's a kind of an example of that towards the bottom. But then instead of having MPI run, you have run job to be able to actually launch jobs. And the important parts there are run job --np, the number of MPI ranks, $p, the number of ranks per node, --block, $ Cobalt, all capital letters, Cobalt _ part name. And then you have to have a colon, the path to your executable, and then any sort of arguments to that executable. There is a run job man page, and there's further documentation available. A lot of our users use script jobs just because it's a lot more convenient to be able to stage things, copy things around, redirect input and output accordingly. Again, already kind of mentioned job dependencies, making sure that if you've got things that must occur in a sequence, again, job 1, making sure that 102 follows job 100, which follow with 104 following. You can set dependencies and create chains. One other nice thing about that chains on Mira is a certain percentage of a job's score or its priority when you use dep chains are inherited from one job to the next and within a dependency chain. So it's, again, in your best interest if you're going to have long-running campaigns where things will require more than 24 hours and come up on each other, it's in your best interest to arrange those dependent jobs and those long campaigns within a depth chain. Again, there's safety. So say we had in this case job 234439 and it fails, it ends with a non-zero exit code. The dependent job 234440 will go into depth fail, and then using QRLS, the same command that you would use to release other holds, release a user hold, you can use to release a dependency hold so that the dependent job 234440 continues on its way. We're not really going to go into too depth with it, but also within script mode, it's possible to have multiple consecutive runs within a single job, multiple simultaneous runs in a single job, combinations of the both. A lot of this feeds into what's referred to as arranging ensemble jobs. So say you're doing something like a material, like a parameter sweep, where you don't have jobs that rise to an 8K partition or larger in size. You have, say, a ton of 512 node jobs. You can arrange those to all, you can bundle them together in an ensemble such that all these 512 node runs occur at the same time within a capability sized partition. We're not going to go into that, but there's plenty of resources within our user guide. And again, your Catalyst or anyone at support.alcf.anl.gov can provide advice and example scripts. So in the case that they're showing, they've taken a 512 node partition and they've broken up into 4 128s, or they've taken a 1024 and broken it up into 2 512s. You can take a 4096, break it up into 2048s. But again, usually what folks are doing is they're bundling together sub capability jobs to create capability jobs. So we had mentioned earlier that we're on a 5-dimensional torus. So rather than mentioning that dimensions are X, Y, Z, we use a mapping which is referred to as A, B, C, E, D, T, where A, B, C, D, and E are 5-dimensional torus coordinates, and T is a CPU number within the block. The rightmost letter of that mapping increases first. So T, then E, then D, then C, then B, then A. So if that mapping doesn't work for you because you have data needs certain proximity, you have certain spacing that you require, just because maybe you've got like an agent model where certain agents are performing certain tasks and they don't want to live next to each other, you can actually change the mapping with the runjob _ mapping environment variable. And again, it's going to go from right to left. So with the mapping string, they've got B, then C, then A, then D, then E, then T. Though that mapping has to match partition mapping. So you cannot overextend in a given direction. And this means that per partition, there are different mappings and different layouts possible, depending on the geometry of that underlying partition. Towards that end, it is possible to create custom mapping within what's referred to as a mapping file. Within the mapping file, instead of specifying the ABCDET layout, you supply a file name that contains 6 coordinates, and that line by line by line by line, and with each row within the file and with each coordinate location within the file specifying what task winds up there. It's a little bit drawn out, but some users, and the majority of users, don't do any specific mapping. However, again, some projects do have geometry sensitive options and do make heavy use of them. Any questions so far? I know there's been relatively heavy topics. Okay. Again, mentioned show res and user res earlier. You can request reservations, which are exclusive use of a partition for a specified group of users for a specific period of time. When you request a reservation, those nodes are yours. Only the user specified may access those partitions. A reservation may exceed our standard wall clock time limit of 24 hours. It may be shorter. Usually what people are looking for in terms of reservation, when users request reservations, it's because there's some sort of debugging that is very highly involved and requires coordination with other project personnel and staff. Or occasionally we will grant reservations if there is some sort of very urgent scientific deadline, say like the editors of Nature or Cell or something come back to you and go, we need these revisions in 24 hours, and you just aren't able to make it through the queue. Reservations, again, should be the absolute exception and not the rule. When requesting reservations, there is a form that has to be filled out. It should, even if it's urgent, it should be about, if you think you're going to need the reservation, put in the request. There is a strict 5 business day lead time requested, and that 5 business days gives operations time to make sure that there will be hardware available, that any sort of other outstanding requests have been arranged or rearranged to allow people to get through. I cannot emphasize enough, if you think you're going to need the reservation, get it in early. Otherwise, it's almost kind of like having one of your undergraduate students come to you the night before and go, can I get an extension on this paper or on this project? It sounds a little harsh, but again, the more lead time you can give us with requests, or even if you have an upcoming series of paper deadlines, working with your Catalyst and letting them know what your project and conference and paper deadlines are going to be, gives them the ability to interact with the scheduling committee and, take things like and make considerations in advance. So I mentioned earlier that it's possible to add users to a given run so that they can control a job, QDEL it, or change parameters. So you can add --run_users with a colon-separated list of usernames. So if you're part of like a large collaboration and you're going out of town during the middle of a campaign, you can add other users to the job so that way they can step in and edit and control the job. The one other thing to think, you can also add the entire project, so --run_project. One important thing to think about is even though you've given them in the QSub permission to change the job parameters in QDEL and QHOLD, it does not give them access to your files. This is part of the reason it's important to try to keep your runs within your project directory and make sure that permissions are appropriately set such that, say, everyone can edit your job scripts and everyone can edit and see both the input and output files within your project, if this is a feature that you're going to be making use of.